Okay, guys, in this part of our lesson on graphing quadratic functions, we are going to use our formulas that we learned in the previous lesson. And our first quadratic function is written in standard form, and we are going to identify the A, the B, and the C value. So our quadratic term, the coefficient is 1. Our linear coefficient is -4, and our constant is 3. So one thing we need to keep in mind is identify the direction, and since our A is a positive value, we know that this parabola turns up, making our vertex, it is going to be a minimum point. We're going to find the AOS, which is the axis of symmetry, and it is a vertical line, so it's going to be x equals some value, and that formula is negative the b value divided by 2 times the a value. So we have negative from the formula. I'm going to insert the b value of -4 divided by 2 times the a value of 1. So this negative is from the formula. This negative is because our value b is negative. So we have a +4 divided by a +2. So x equals 2 is that vertical line that divides our parabola into 2 halves. Now, remember, the AOS value, that x value, is the x coordinate of your vertex. Now to find the y, because a vertex is a point, so x comma y, to find the y, we simply plug in that x value into the function. Everywhere we see an x, we're going to put the x value of 2. So 2 squared minus 4 times 2 plus 3. Order of operations, we're going to do our exponents. We're going to multiply, and then we're going to combine. I like to combine my signs that are the same, so that is 7 minus 8. So the y coordinate of our vertex is -1. Okay, and we will be doing a sketch. So let's go ahead and just do that part roughly. So x equals 2. This is going to be our AOS. And then 2 comma -1. We know the graph turns up. This is super important to go ahead and sketch this out, because it does tell me that this parabola will indeed have 2 real roots. There will be 2 x-intercepts. And our vertex again was the lowest point of our parabola. To find the y-intercept, that is when x is 0. So we are going to insert 0 everywhere we see an x. And anytime we're multiplying with 0, we're just going to be left here with our c value. So our y-intercept is simply the c value, but the reason is because we inserted 0 for x. So the y-intercept, another point on the graph, is a 0, 3. And then our x-intercepts, we know we're going to have 2 real roots because we already did a quick sketch. You see, guys, if this was my vertex and this had been a negative quadratic and it turned down, then we would not have any x-intercept, so I wouldn't even need to proceed to try to find any real roots. So we're going to see if this factors nicely. So to find the x-intercepts, we plug in 0 for y. We're going to factor x squared and the +3. So x squared is x times x. And then 3, we have 1, our a, times c is 3, and then we have -4 on the bottom. So our top number using our graphic organizer is a times c, and then our bottom number is the b value. So what times what gives us +3 that adds up to -4? So -1 and -3 or vice versa. Order does not matter here. So a -3 times a -1 is +3 and it adds up to -4. Now, when our A value, recall, is 1, like it is here, we have a 1 here, we do not have to go through all the grouping process. We can just do this quick trick and then set each of these equal to 0, and one of our x-intercepts is going to be 3, 0, and our other x-intercept, because I add 1 to both sides, is going to be 1, 0. So I'm going to write these as ordered pairs, and then we can do a sketch. So when we do the sketch, you can see here that our AOS was x equals 2. Our vertex was 2, -1, 1, 0, and 3, 0 were our x-intercepts, our roots, our zeros, and then here we have our y-intercept is 0, 3. Now, if we wanted a fifth point, we could simply, if we needed to list a fifth point, I could simply use the corresponding point of the y-intercept. It is 2 units on the left of the AOS, so the corresponding 2 units on the right would be this point here, 4, 3. So if you ever need another point, I like to do the corresponding point of the y-intercept. Okay, let's talk about domain. This is what possible x values. We are not limited. We can see that this parabola is growing left and right, so we are not restricted with any x values. We are restricted with our range values. The least y value that's going to be a part of this function is -1. I am going to use a bracket because it's included, and then the y values continue to positive infinity. The interval of increase, so this is where we need our AOS. So remember, the AOS is x equals 2. So the value 2 is going to be used here and here. So on the right side of the AOS, this graph is increasing. It's going up. It has what we would call a positive slope. It is going up. So from 2 to positive infinity in this region, the parabola is increasing. And then on the left side of the AOS, our parabola is decreasing. It has what we would call a negative slope. So in the region negative infinity up to our 2 value, it is decreasing. Now I am going to use parentheses with this because at x equals 2, this parabola is neither increasing nor decreasing. It's just a neutral point. It's the turning point. The interval of positive, so what x values give me positive y values? So let me just try a different color here so you can see, and let me erase some of this so we can see a little bit more clear here. And so we can see that this graph is positive here and here. That means the y values are positive, and above 0, y is positive. And then the graph has negative y values from here to here, which that is 1 to 3. Okay, let's go back and make this a bit bigger so you can see. So the positive, the x values that make the graph have positive y values is from negative infinity up until the value of 1. This is 1, 0, so y is not positive, so I'm not going to use a bracket. It's not positive or negative because it's just 1, 0. So I'm just going to use a parenthesis, and then we're going to use our union symbol, and then it picks back up when x is 3. Again, this is 3 comma 0. Y is not positive, it's not negative, but it's not positive, so we don't include the 3 value, and then all the way to positive infinity. So then in between our 1 and 3, the y values are negative. So at 1 comma 0, and then up until 3 comma 0, from 1 to 3, the graph has negative y values. But again, we're not going to include the 1 and 3 because that's 1 comma 0, and 0 is not a negative value. In behavior, we are just concerned with the ends. We have a left end of the parabola and we have a right end of the parabola. So as my x values decrease, as the x values approach negative infinity, the y values, f of x, so as my x values get smaller, my y values are getting larger, headed toward positive infinity. So this is the left side of our graph, the left end. Then let's talk about the right end. As our x values approach positive infinity, as the x values approach positive infinity, as they get larger, as they increase, the y values also increase. So this is the right end of the graph. So when we're talking about quadratics, make sure that either both ends are going up toward positive